This is the second part of the video covering the Google GenAI processor library. The first part we covered the basic constructs of the streaming library, and now we'll look at using the GenAI models themselves as processors. So this is a GenAI processor. You define it by through this GenAI model class, which is in the core of this library. Okay, and so this is a project GenAI, and then you concatenate, sequentialize another text, which is the lowercase with the GNR processor. So you take the input, which is explain the concept John, 2 sentences, and it passes through the. So it's extremely easy. The library makes it extremely easy to directly call these LLM APIs by simple sequential composition. This is where the magic of the composition really starts shining. And as we interact with more complex models, the stream programming, the magic or the beauty of stream programming will show more and more. Okay, so call this here, and uh, again for each part is output. So let's see what happens when you run it. Okay, so large models are everything is lowercase after the output. Everything is lowercase. That shows how both of these two things are working. And yeah, there's more constructs about time to first token, and here's more complicated example where you interact with a live API where you declare a live processor that response modality is audio. Okay, and how do you set it up? You define processor and collect audio. So you ask the input streams, how are you today? The substream name, and you get an output, audio output from the model, which is collected here. So this is an interesting illustration how it handles the audio data byte by byte. The content is audio. It accumulates all of those parts, bytes in those parts in a single accumulator variable. And when the thing is done, then you send out a frame processor part with the whole audio bytes. Okay, so this, yeah, so let me try if this works. It's running output the.
I am doing well, thank you for asking. How are you today?
Okay, that's what the output is. So this is the, you declare again a live processor. You pass in a stream, and then yeah, it's like it says, you're only sending text here, but also add audio images, which comes from camera micro. So you can, by using these primitives, you can build extremely complicated applications which work over real time, over text that you send, audio, thing that you speak, and images, for example, extended from video. Right, so next is part processors, which are the singleton, which work over singleton data pieces, and the details of how they exactly work, and uh, how do you how you have to understand how part processors work concurrently over the incoming data items, and you can convert a part processor into a processor which works directly on async iterable and not the parts. So besides the confusing name, it's also the semantics are a bit confusing. So you have to keep in mind that which one you are using at that point. What is the input data type? Is it async iterable or just a part? And similarly, you can define parallel execution. There's a handy // construct which is these processes parts can execute in parallel. Like I showed, the audio case, it could handle audio data, and we have to there's special handling for that. We have to collect the bytes into audio and then play it. Similarly, for image, you can send image part directly and get the output. So the next thing is about iterables to async iterables. You can convert asynchronous streams into synchronous streams, and you can gather the stream into a list. Okay. You can also split and merge the streams. So there's a split operator which splits the stream in two parts. You can append, you can work on each of those streams independently and then use a merge operator. So this is a very nice split and merge operator can be used to implement parallel pipelines which over content that is similar. And then again combine them into a single pipeline. This is where the real the deeper semantics of the stream programming starts shining. What is tricky is how to map your intent to these operators. Which of these operators is most suitable, best suitable for the function that you want to implement. Okay, there's some more detail, and also not only lists, you can take different sources, generators, essentially arbitrary generators. For example, the terminal input generator, which generates the text that's typed by the user. And using process.source, you can automatically turn your generator into a processor. So you can create so for example, terminal input plus audio goes to the live model. This is your whole pipeline. This is very succinct description of the pipeline. And you can really write elegant stream programs which do complex tasks using the bus. Yeah. So that was a quick overview of the core concepts of the processor library. You can build, and the key concepts are data item, two kinds of processors, and you can define if then else, sequential composition, parallel composition, split and merge operators, and make very complex pipeline that involve models. I'll be covering more applications that I'll build with this process intro. So stay tuned.